Hello everyone, welcome to this session. Today we're starting a new chapter. So far in our previous video, we discussed about the various these compounds. So today we discussed basically about the formula bonding and the nomenclature. So today let's move on to the new chapter, that is nonmetals and their compounds. We're still with the metals and their compounds in the other chapter, which we are still covering. So this is the new chapter. We'll be discussing both of them. So we'll start with the introduction to the nanometals and their functions. So here we'll see the various, uh, we'll start with the concept of this, the concept of the nanometals and their compounds. But specifically, let's start discussing the general chemical properties of the nanometals. So seeing the general chemical properties of the nanometals is one of the things that will get us to understand these nanometals. The nanometals are very reactive, and most of them react with other elements to form different compounds. So this we have to note that the nanometals are just very reactive, and just most of them they react with other elements to form different compounds. Uh, the following are just important chemical properties of the nanometals, which are connected with their tendency towards electron gain in the course of the formation of the compounds. So we'll see some of the chemical properties with connected or with relating to their tendencies towards the electron gain in the course of their formation of compounds or in the bonding formation. Now, the first one that the oxide of a nanometal is either acidic or neutral, but never basic. So this is the first general chemical property of nanometals, whereby the oxides of these nanometals is either acidic or neutral, but it can never be basic. The oxide of a nanometal is a covalent compound, so that we have to note it also. And the basic, being an acid, it combines with water just to form an acid. Take an example, as you can see here, the various examples. Uh, Take an example, carbon dioxide gas reacts with this liquid just to form this hydrogen carbonate. Also, as you can see, there are other examples as from there. So the oxides of these nonmetals, they are just either acidic or neutral, basically, but they can never be as base. Just the oxides of just these nanometals is ones of the covalent compounds. So yes, the case of this being acidic, they combine with just water to form acid. As you can see, all these are just examples of how these various uh, compounds they react with water, they will still form acids. Up the clear. Moving on. The other property, the chemical general property, that a nonmetal never replaces hydrogen in acid to form a salt. So this you have to notice that a nonmetal will never replace hydrogen in an acid to form a salt, specifically when there's this bonding or there's this reaction. Now, this is because the replacement of hydrogen in an acid is due to the fact that hydrogen ions accepts electrons supplied by a metallic atom. So this is the reason why the nanometal will never replace hydrogen in an acid, because it's simply the replacement of hydrogen in an acid is due to the fact that the hydrogen ions they just accept electrons supplied by the metallic atom. And here is just how it is that this the hydrogen ion will just lead up to this hydrogen gas. Of the sphere, a nanometal is an electron acceptor, and so it cannot release electrons to hydrogen ions in the solution. So that has to be noted, taken from the second point, that is the other general chemical property of nanometal. The other chemical property that nanometals they form covalent hydroxides. For example, the behavior of the phosphorus forming spherites is well known, as you can see in the reaction. So the nanometals they form covalent hydroxides. This potassium reacts with this chlorine gas, leads to potassium chloride. So that's how it is. The covalent chloride, like this, is usually a volatile liquid, meaning that a non-electrolyte and rapidly hydrolyzed by water. So that's what is formed. As you can see in the reaction, this is how the reaction of this the potassium chloride that is formed when it reacts with the water. It becomes this as it forms. It's usually as it is a volatile liquid and a non-electrolyte and rapidly hydrolyzed with this water. I hope that's clear. So these properties are characteristic of non-metallic hydroxides, except for the this CL4, which is not hydrolyzed by water. So that you have to note it also. Moving on, the other general chemical property of nanometals is that nanometals, they combine with hydrogen to form many hydrides. So this is the other general property whereby we have to know that the nanometals generally they combine with this hydrogen just to form many hydrides. A covalent compound is formed by equal sharing of the electrons between or among the combining atoms. So that's what it is. For example, the methane, ammonia, hydrogen chloride, and the hydrogen sulfide are just the examples, the ones that are the covalent compounds. The other general chemical property that the nanometals are oxidizing agents. As discussed earlier, that the nanometals they accept the electrons from the other substances, so they are generally they are oxidizing agents. Therefore, they are called oxidizing agents just because upon accepting the electrons, the substances donating these electrons are oxidized. So that's the reason why they are oxidizing agents. So they act as the agents for the oxidation of the other substances. So I hope that's all clear. Thank you for listening. We've started discussing this on new chapter that is nanometals and their compounds. We've seen a simple introduction to these nanometals, specifically talking about the general chemical properties of the nanometals. I hope that's all clear and thank you.